Do you feel the vibes?
Hello. Okay, so in this lesson, we're going to talk about solving logarithmic equations. So take a look at this first type. Basically, what you see here is we have one logarithm on one side of the equation, right? So for this, you have to use what we learned, that a logarithm is the same thing as an exponent. So when you have this logarithm set up here, the answer to the logarithm we know is the exponent. And every exponent needs a base. That means this is the base. So the way I write that is I say 8 to the power of 4 over 3 is equal to x. So now what I have to do is solve that, right? So that means x is equal to, okay, so I have 4 over 3 here. That means that's going to be the cube root of 8 to the power of 4. We know that the cube root of 8 is 2 to the power of 4, so x is 16. Okay, next one. Again, this is the exponent, and this is the base. So I have x is equal to 16 to the power of 3 over 2. Again, fractional exponent means write in root form. If it's over 2, that means this is a square root of 16 to the power of 3. All right, so I know that the square root of 16 is 4. So x is equal to 4 cubed, which is equal to 64. Okay, next one. Again, x is the base. 5 over 2 is the exponent. So x to the 5 over 2 is equal to 32. Okay, so now this is a different situation. When you have x to the power of 5 over 2, what you have to do is you have to raise this to the power of 2 over 5. Raise this to the power of 2 over 5. So remember, this and this have to be reciprocals of each other. So x is 32 to the power of 2 over 5, which means x is fifth root of 32 to the power of 2. Now, fifth root of 32 is 2 to the power of 2. That's 4. Lastly, here, 8 is the base. X is the exponent. So I have 8 to the power of x is equal to 1/2. Okay, this is a different situation from the previous one, because in the previous one, at x to the power of an exponent, now I have a number to the power of x. To do this, I have to do what I did in the last lesson, which means I write the 8 as 2 cubed to the power of x. And this one, 1/2 is 2 to the power of -1. So now, when the bases are the same, I can set those two equal to each other. So I have 3x is equal to -1. X is -1/3. Okay, in all of these cases, you had one logarithm on one side of the equation. Now, what if you have a logarithm on both sides of the equation? When you have that, if you have identical logs, log b, then you can automatically set the insides equal to each other. So here I have log base 4, log base 4. Now remember, this doesn't work if you have log base 4 and log base 7, let's say, okay? But when they're identical, we can set the insides equal to each other. X squared is equal to -6 minus 8, -6x minus 8. Now the logarithm goes away, so this just becomes a simple algebraic equation. I'm actually just going to write that over this way so I have some room later. Okay, to solve this, I have to bring everything to the other side. So add 6x to both sides. Add 8 to both sides. Now we have to factor. So x plus 2 plus 4. x is negative 2, x is negative 4. But in the case of logarithms like this, you have to check to see that your answer works. The way to do that is the following. Let's first check x equals negative 2. I'm going to take negative 2 and I have to plug it into the original equation of the logs. So I have log base 4, negative 2 squared, equal to log base 4, negative 6 times negative 2 minus 8. Okay, so here I have log base 4 of 4, log base 4, 4 again, so these do work. Okay, next, let's check x equals negative 4. Log base 4, negative 4 squared, log base 4, negative 6 times negative 4 minus 8. So what do we have? This is log base 4, 16. This is log base 4, 16. Those also work. That means both of these are solutions. Okay, let's take a look at this next one. Log 5 means I can set these two equal to each other. X squared minus 10 equals to 3x. Bring the 3x to the other side. X squared minus 3x minus 10. Factor x minus 5, x plus 2. So x equals 5, negative 2. Okay, so let's check. Let's check x equals 5. I have log base 5, 5 squared minus 10. Log base 5, 3 times 5. That'll be 15 eventually. So here, log base 5, 25 minus 10 is 15. Log base 5, 15, that works. Let's do x equals negative 2. Log base 5, all right, so negative 2 in parentheses squared minus 10. Log base 5, 3 times negative 2. Okay, so look, in both of these cases, here I get log base 5. 4 minus 10 is negative 6. The minute you end up with a negative number inside the log, you know that this does not work. It is illegal to have that. So that we throw away. The only answer is x equals 5. All right, next, we set these two equal to each other. So x squared minus 4 equals 3x. Subtract the 3x. X minus 4, x plus 1 equal to 0. So x is 4 and minus 1. Okay, so let's check now. X equals 4. Well, let's see. Log base 2. 4 squared minus 4. Log base 2, 3 times 4. So here I have log base 2. What is this? 16 minus 4, 12. Equals log base 2 of 12. Okay, that works. Log base 4 of minus 1, right? So I'm going to have minus 1 squared minus 4. Okay, so here already, negative 1 squared is 1. Minus 4, I'm going to get log of a negative number. I already know that this failed, so I throw it away. And my only answer is x equals 4. Okay, here, set these equal to each other. X squared minus 15 equal to 2x. X squared minus 2x minus 15. X minus 5, x plus 3 equal to 0. X equals 5 and negative 3. All right, so let's see. The x equals 5, log base 5. 5 squared is going to be 25 minus 15 equals log base 5, 2 times 5. So I have log 10, those are equal, so that works. Negative 3, I have log base 5 Negative 3 squared is 9 minus 15. Again, I know that that's going to end up as a logarithm of a negative number. Throw that away. So the only thing that I have left, again, is x equals 5. So one answer. And that is section 4.